So in this question, we're given 4 different situations where we're looking for how substance X will affect that particular plant. So you've got D, which is our control because there's no substance X and the stem's intact. E has X, but it still has the stem intact. F has the phloem removed, and G has the stem cooled down. And then we're also given the results of the experiment after 6 weeks. We're given the mean number of roots per length of stem. So the question asks about the mass flow hypothesis is used to explain the movement of substances through the phloem. Evaluate whether the information from this investigation supports this hypothesis. Do not consider statistical analysis. So this question doesn't want us to explain what mass flow is, it wants us to explain, does the evidence from this experiment support the idea of mass flow? So mass flow is the movement of sucrose that is produced in the source, which is usually the leaf, so that will be produced by photosynthesis. The sucrose is then actively loaded into the sieve tubes of the phloem, and that will then cause a decrease in water potential in the phloem. Therefore, water will then move from the xylem into the phloem down the water potential gradient by osmosis. Once you've now got a large volume of liquid at the top of the stem, then you've increased the hydrostatic pressure. So you have a very high hydrostatic pressure at the top of the stem and a lower hydrostatic pressure at the bottom. So therefore, the liquid will move from a high pressure to a lower pressure, which is the idea of mass flow. Once the sucrose has then got to the sink, which in this case is the roots, then the sucrose will be actively loaded into those roots. So it's all about the idea of the movement being due to pressure. So this question wants us to see, does this evidence support this? So in support of the mass flow, we can see that with F, when the phloem was removed, if we look at the results and how that affected the number of stems, we can see the length of the roots, we can see that there has been a decrease. So it does show that the phloem is involved in that movement. With G, we can also see that G has been cooled down to 4 degrees. Now, because the sucrose is actively loaded from the source, which is usually the leaf, to then go into the phloem sieve tube, if it's cooled to 4 degrees, this is going to reduce that movement. It's going to slow that movement down, which means that the active transport is going to be slower. So if this was to support the mass flow hypothesis, we would expect G to have a lower amount of roots after the 6 weeks, and it does. So we've got the idea that G shows active transport is involved because that is slowed down, and F shows the idea of the phloem being involved to move the substance from the source, which is the agar, down to the sink, which is the roots. But also in terms of this experiment, if we're evaluating, we've got to look at what evidence is there against it. So in F, we can see they've removed the phloem, but during ringing experiments, that shows evidence for mass flow. When the phloem is removed, we get a bulge at the top of the ringing, and this is not the case in F. We can also see that the substance X may move its way through the plant. However, we don't know what the role of that is. We don't know if that's caused by the hydrostatic pressure or the water movement or osmosis. It could simply be due to gravity because it's going from the top to the bottom in all of these cases. There's also the idea that the roots are grown without the phloem. Even with F, when the phloem has been interrupted, it does still have a 4 for the mean number of roots grown per stem. So there's also no leaves or no sugars, and there's no photosynthesis going on in this experiment.